Yeah. And then after that, after this, they'll collect the data. We'll do the describe the data, and Ashley will be writing that up. But again, we can all work together at looking for the data.
And when's that one due?
Say that again?
I think it's due like the 12th or something, isn't it?
Yeah, we had about 2 weeks for the data to collect it, and now everything's due after that. Like, the data is due this week, and then I think next week, or the 12th. Yeah.
I think mine was due on the 18th, if I remember, because I was just looking at it to see what I had to do.
Can I take 10 seconds on
I know, I've had so many dates flying my way lately.
So, especially because it's coming to the end of the semester.
Yeah, no kidding.
But for now, we can worry about our studies side for the test. I can say a prayer and then we can just get started.
Awesome. It's 45 questions, by the way.
Ugh.
Oh gosh.
But only 25 of them, I think it was, are fill in the blank.
We can do that. Awesome. Yeah. Heavenly Father, thank you for this wonderful day, for being with us, and thank you for this group that we have. Please be with us now as we do the review, that we remember the things that we have studied, and that we'll be able to help one another out to prepare for this next exam coming up. We're going to redeem and love you, Susie, and Jesus Christ.
Amen.
Thank you, Michaela.
Yes. Okay. Open it.
Okay.
Oh no, first are the deciding studies.
The first 8 are. I think it was 8.
Is this one of the ones that he gave us the? No.
So should we read them out loud?
Oh yeah, do you want to do the first one?
Oh no, sure. In an article in the Journal of Small Business Management, successful startup businesses in the United States and Korea were compared. One set of data compared educational level of people who manage successful startup companies in the United States and Korea. You want to determine if education level of managers of successful startup companies is independent of the country they are from. Which hypothesis test would be most appropriate?
For this one, I think it'd be the chi-square test of independence, just 'cause, like, just thinking about the different tests we did, chi-square doesn't work with any numbers really, but we have to weight the cases.
It's categorical. Because
Yeah.
Mm-hmm.
Yeah.
And it's
So you're saying the chi-squared one?
So we very last.
I spoke to Amber last week because I was like, there are so many of those cases and I just get confused. And she sent me a sheet. I don't know if are you familiar with this? It's called Decision Tree for Correct Tests. Can you see it? There.
That's kind of cool.
And I don't know, it really helped me. So I could send it to you guys if you want it. I don't know.
Yes.
That'd be awesome.
Okay, I could read the third question.
Okay.
A human resources manager reported data from a recent involuntary reduction in force at her company. You are an attorney and want to determine if age discrimination was a factor. It is illegal to discriminate against employees because of age. The company reported the number of employees in 2 groups, 40 years old or younger and 40 years old, and over 40 years old. They also reported the number of employees in each group who were terminated. You want to determine if both age groups were treated equally, which hypothesis test would be most appropriate for this analysis. So again, it's categorical, right?
I was
And
thinking the test of two portions.
yeah,
Yeah, that's what I was thinking.
because it's categorical and it's two groups. So
Yes. I can take the fourth one. The survey was conducted by a group of state explorers. A random sample of 2,406 adults completed the survey. A total of 248 were classified as heavy players. Of these, 152 were male. We want to determine if the proportions of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. Which hypothesis test would be most appropriate for this analysis?
I think it's also tested two proportions.
Well, I do think it's a proportion, but is it one or two?
I was thinking it was one because we already have the percentage and everything of one of them. So we just have to figure out the other one.
Yeah, that's what I thought.
Yeah, makes sense.
I think it's the test of one.
A student project compared the effectiveness of two different combination locks. One of the locks turned clockwise first, and the other lock turned counterclockwise first. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The time it took them to open the lock was recorded. They wanted to determine if one of the locks is easier to open, which hypothesis test would be most appropriate.
Is it paired sample?
That's what I thought it was. You have like the one person doing one who has to do the other one because they're comparing that one person to both. Yeah, I think it would be all right.
Okay.
Jamie, you want to start us again with question 5?
Yeah. A bank employs two appraisers. A bank employs two appraisers. When approving borrowers for mortgages, it is imperative that the appraisers value the same types of properties consistently. To make sure this is the case, the bank evaluates 6 properties that both appraisers had recently valued. Which confidence interval would be most appropriate for this study?
Okay, so there's 2 appraisers and there are 6 properties.
Wouldn't that be
Would it be a no? No, it's not even. It's not even a choice there. No.
Is it independent samples?
You would need 2 sample independent.
I think it'd be the paired or the independent one. It was compared that the appraisers value of the same type. Well, I think it's that just because they're
Which one?
like the same things. And I think it's the paired sample of T confidence because it's the same that they're appraising.
Because it's the same house.
Yeah. They have to.
So which one? A, B, C, D?
Paired a C. Paired sample T confidence.
Per sample T confidence interval?
Yeah, paired sample.
Yeah, I can see it. Yeah.
Okay, I read. In a Wall Street Journal article on satisfaction with career path, the percentage of psychology majors reporting they were satisfied with their career path reported. The same data was also reported for accounting majors. We decided to construct a 95% confidence interval to see if the observed difference is significant. Which confidence interval will be most appropriate for this study? So there are two groups.
Isn't it one sample T? No,
No,
because they have
think it-
something.
For me, looking at it, it would be confidence interval for two proportions because they're rating the satisfaction, so categorical, of psychology majors and also accounting majors. So you have the two groups and how they were satisfied. That's why I think it's,
Two proportions.
That's what I
yeah.
mean. Not like they're just asking if they're satisfied or not. It's not like data.
Makes sense.
Okay, I have a question. Double stuffed Oreo cookies are supposed to have twice the filling of regular Oreo cookies. You and some friends decide you want to know if that is a true assertion by the company who makes them. You take a sample of 55 double stuffed Oreo cookies and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos. Which confidence interval would be most appropriate for this study? Okay. So we have the set data of like this is what the package says is all the stuffed Oreos, and now we're just doing that. So I think that's kind of like what.
I think you're comparing double stuff to single regular Oreos.
Would it be independent samples?
I was thinking independent sample. Yeah.
Yeah. I don't even think independent, or if it's just if they're going off of what the package says, then it would be one sample T because that's kind of what our test is with the height. But yeah, if it's just comparing the two, then I would think it's the independent. Okay.
A confidence interval to estimate the true mean filling amount of double stuffed compared to the filling amount in regular. So that makes it independent, right?
Two sample independent T confidence interval.
Wait, Mildred, what one did you think it was?
I'm sorry, I think that is A, B, C, D, independent samples.
That's what I thought.
Okay, yeah.
Which of the following best defines the notion of the significance level of a hypothesis test?
Isn't it B?
Yes, because I read number 10, and 10 is which one of the following best defines the notion of the p-value of hypothesis. Yeah, those ones confuse me, so I think question 9 is B, which would make 10 the probability of observing. I remember that from another test.
Which
Wait.
one? B is the probability of type 1 error.
Yeah, for question
9? Yeah.
And then for 10, you think it's C?
Yeah, I remember that being on another quiz that we took, and that's the answer that I put, and it was correct. With probably observing samples more extreme than actual change, like you're just trying to prove the null hypothesis. The p-value determines it.
I don't know. I don't get that.
Everyone good to move to question 11?
Do you want to read 11, Jamie?
Oh yeah. Suppose you create a 95% confidence interval for a mean and get 10, 20, You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? Isn't that A?
I think that's
Um, I have something that my tutor told me about that. Like, it tells you like which wording. Hold on. I know I have it somewhere. Hold on. It was.
it's
Yeah.
not B.
Yeah, it's 95 of all 95.
B, right?
Yeah.
Yeah, a trick for those ones that I just remember is if they ask that question, it's always going to be the two numbers, 95 of all 95. So that just helps you on the head.
Mhm.
Look for the one with the two 95.
Use the following information to answer the next three questions. You take a simple random sample of 100 adults from a town in the western United States to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion or percentage of people in town who invest in the stock market is P. As P equals 30%. The question is, what is the mean of the distribution of the sample proportion? What is the mean? It's the same 30%, isn't it?
Yeah, but I think it's written in
So how is it written?
0.30.
Okay.
The sample proportion is equal to P. So then you just put
P. So
0.30.
what should we put? 30 or 3 or point? I mean, 0.300 or 0.30? 0.30, right?
Yeah, 0.30. Okay.
So the only
number
reason.
13,
Sorry.
No, go ahead.
I was just going to say, so the only reason that we're able to do that is because the sample size was over 30, right?
No, because P is equal to the mean, right? Isn't it?
Yeah. For this one, the sample proportion is equal to P. So then it will always be what the P value is, no matter what.
Okay.
So for 13, what is the standard deviation of the distribution of the sample proportion?
What is the standard?
I can't remember all the equations again.
Oh gosh.
I can't even remember that. Wait. The standard deviation, would you use the standard deviation of p-hat, or is this like older stuff?
It's going to be, it was in lesson 16, describing categorical data, and it's that standard deviation. So P hat equals,
The square root.
yeah.
Okay. That
So
one.
P hat equals square root P times 1 minus P over N.
Okay.
If you guys want to do,
Repeat
I just,
hat is what?
so this
Hat
one,
equals?
we are,
That. Sorry, my handwriting's really sloppy with that.
That's it.
Okay.
Thank you.
I got 0.046.
Yeah, guys, okay. So for 13, it's 0.046. So 14.
First what? 0.46?
Yeah, for 13 is 0.046.
What is the probability that the random sample of the sample proportion less than?
Is this n equals z star divided by 2m?
Does it have a prior estimate before? Right. It's not looking for the margin of error, is it?
No, it's the probability.
So which one do you think is the formula for this one?
I don't know yet.
Okay, we have the standard deviation. Okay. No, we have the probability P is equal to 0.3. The number is 100 and 46 is the proportion, which is P hat.
Which one's P hat? Do you say
P hat is 0.46. So we have, I think that no standard deviation. I think that is Z is equal to value minus the mean divided by the standard deviation. Because we need a Z-score to be able to know the proportion, right?
Right, yeah, I think you're on.
So
So 0.25 minus 0.30 divided by 0.046.
Yeah. So is it the 0.25 that goes first or the 0.30? I think that's where I get mixed up.
I think it's the 0.25 because that's the value and the 0.30 is the mean.
Minus 30 divided by the standard deviation, divided by 0.46. So
I'm getting, using that I got negative 1.086.
That's what I got as well, and then I plugged it into the applet, only did the less than because it wants less than 0.25 and got 0.138 or 139 rounding.
So you stick this number where the z-score is, right?
Yeah, and then you just unshade the right, just keep the left shaded, and you get 0.1385.
That's what I'm getting to.
I think that's the answer.
So what did you put?
For the answer,
Let's
for
put
the
139.
answer, yeah,
it would be
1.39.
0.139, right?
Okay.
If you said 1.139, then yes. So this is finding. Oh, yeah.
Someone just had the margin of error equation, right?
Yeah. Well, I have 3. It's just depending on like if they require an estimate or not.
Is it the,
I don't know. I haven't read it yet.
Oh, the margin of. Are you just wondering what the formula is?
for this specific one?
Okay, which one are we doing now?
Oh,
Who's
for
reading?
question 15. I get what you're saying now. Okay. So, here's the following information to answer the next 7 questions. Acupro is meant to control hypertension. In clinical trials of Acupro, 2,142 subjects were divided into 2 groups. The 1,563 subjects in the experimental group received Acupro. The 579 subjects in the control group received a placebo. Of the 1,563 in the experiment group, 61 experienced dizziness as a side effect. Of the 579 subjects of the control group, 15 experienced dizziness as a side effect. So P1 be the true proportion of people who experience dizziness while taking Acupro. Let P2 be the true proportion of people who experience dizziness and do not take Acupro. So we need to use our little Excel sheet.
For the 2 proportions, right?
Mm-hmm. Because we need to find the lower and upper bound first.
What are they trying? What's that?
Now we should assume that it's 95% confidence interval, right?
Yeah. Yep.
And
What do we put for the type of test? Just not equal?
I think so.
I think so, yeah.
Okay.
What is the margin of error? But we have to calculate the margin of error. It doesn't
Yeah,
give us
but
the
you need the
margin.
confidence interval first.
Okay, so it's minus 0.003, right?
Wait. So what did you plug in for the X1?
X1 61.
Out of 5, and then N1 is 579.
And N1 is 1563, 1563.
Okay.
No. I'm sorry. Let me see. 579
Mildred, what did you say you got for the lower bound?
The lower bound, on the lower bound is minus 0.003.
Okay, yeah, that's what I got as well.
Okay, I'm still
And then,
I put in the boxes. So I put 61 for the first one, 1563 for the second one.
X2 is 15 and N2 is 579.
Are you guys talking about what you got for the confidence interval?
yeah, so you have to find the confidence interval first. And so I just skipped the margin of error one to find the lower and upper.
For the
Because-
lower one, I got like negative 0.971
How?
somehow. I
Yeah.
put 61 for the first box, 1,563 for the second, 15 for X2, and for N2, 579.
Yeah, and then 95% confidence interval.
Yeah, and then not equals for the type of test, right?
Uh-huh, yeah.
Yeah, that's exactly what I put in.
I got
And the two, I don't know.
confidence interval for P1 minus 0.003 and for
Mhm.
P2 0.029.
Yeah, that's what I got as well. I got the same as Mildred.
So
No,
what'd
no,
you get for the
wait,
lower one?
negative 0.003. And then the upper is 0.029. And then to find the margin of error,
It's upper bound minus lower bound divided by 2.
yep. So, so 0.029 minus negative 0.003 divided by 2.
I got 0.1465.
I got 0.016.
That's what I got. 0.016 is what I got as well. Okay. Does anyone need help with 15, 16, or 17?
What do you got? 0.016?
Yeah.
Yes. The lower and upper 18. Okay. So it says new experiences is different in the proportion of control groups. So with different, we know it's just the equal signs. So equal and not equal.
So it's A.
I think it'd be, yeah.
Is A.
And the value,
Is 145A. 1.45. 1.458.
p-value, looks like the p-value is 0.145.
So we failed to reject, right?
Correct.
So the
So
question is there.
I think it's the last one. No, I failed to reject the HO. The null hypothesis. Okay. Hmm.
Do you want to read?
Yeah. A survey was conducted 1,479 random selected adults aged 18 and older. They were asked, are you a morning or night person? The hypothesis for study part is being a morning or evening person independent of age. And the alternative is being a morning or evening person is not independent of age.
Oh gosh, I hate this.
So we have to put it in the VMware.
Now we have to do the SPSS. Ah,
Is this the Chi-Square thing?
yeah.
Yeah.
I think that I should have bought that program, you know, so just to avoid going into that thing.
Okay, so in the first box, I just do morning, morning, evening, evening, right?
Did you check if we're gonna need the SPSS with specific problems?
Huh?
Do you know if we
What?
need SPSS for specific problems, like if, you know, when they gave us the data, or not?
We only use SPSS in the test for, I think it's for the chi-squared.
Oh, okay.
That's because like the two proportions you use Excel, the proportion.
So in the
Okay.
first column, if you
That's
put
one
morning,
overload.
evening, evening, is the next column age?
Let me look, hold on. I'm just putting in evening. I would put in the next column, yeah, age. Or wait, you don't put, yeah, you put like 18 to 29,
Yeah.
or wait, maybe you do, since there's 4, maybe you do morning 4 times, evening 4 times, because there's 4 boxes.
Oh.
Okay, so on the first variable, let me see. Okay.
Did you even maybe put the ages first, or do the morning and evening have to go first?
I would do morning first, then do morning first. I would.
Okay.
And my tutor said make sure you put, if you're going to do all lowercase, you do all lowercase. If you're going to do all uppercase, do all uppercase, because it'll mess, even if you have like one uppercase M or one lowercase m. It'll screw
I
it up.
know. Yeah, it did that to me in one problem.
Yeah.
You have to really do it exactly, like type it exactly the same. Otherwise, it'll mess up everything. Okay, so how did you arrange in the variable? The first variable is morning, evening.
This one's mine. So, can you see it?
I can't see.
So I put in the first 4 mornings and then 4 evenings. And then the second column, I put 18 to 29 for the first one, 30 to 49 for the second.
Yeah, but you're not doing the variable view first?
Variable? What do you mean?
On the second page, where you have to do, what are you doing? What page are you doing? data view or the variable view?
Oh, first you do the data view, and then you go to the variable view, and you rename the variances so you understand like what they are.
Okay, so anyway, so on the data view, the first column, what are you putting? Morning, evening, morning, evening, morning, evening?
No, I'm doing it all mornings together and then all evenings together. This is like my favorite. I love making these. I think they're fun.
I'm glad you did. These ones stress me out.
So how did you call your first variable?
I just
Times?
like it could do whatever. It doesn't matter. So you could just say either or sleep or whatever. I don't know.
Okay,
It doesn't matter. You just need to know so you can distinguish what's what.
yeah. So the second one should be ages, and then you put
Yeah, and then count.
18 to 29.
Okay, I got my charts if anyone has theirs.
I have, yeah.
Okay, so for the test statistic, or calculate test statistic, I got 6.579.
That's what I got. And then for the p-value, did you get 0.087 once it's rounded?
0.87, yeah.
That's what I got as well. Okay, well, if you all got that, that's kind of nice. Alright. Well, question 24. Should you reject the null or not?
No, because the value is greater. So would it be
D.
Yeah, D. We conclude, so since we failed to reject it, there's insufficient evidence that the person is not.
opposite? I have it written down, so do you... I swear this one's different. Hold on. Where is it? I swear I wrote it down so it was like opposite. Maybe I'm wrong. Hold on. Maybe I'm
Let
wrong.
me ask you something. I'm a little confused now. I did it so many times. Okay, so the first column you have 4 mornings,
Yeah.
4 evenings, and that's it, right? 4 mornings and 4 evenings, and then now you just put on the count the amounts, right?
Wait, what?
On the first column, you have morning, 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 and then you have 4 evenings, evening, right?
Yeah.
And then on the second, you have 18 to 29, 30 to 49, whatever, repeat it again.
Yeah.
And then you enter the values, okay.
Yeah.
And then for
So I
25, it's D.
yeah. This is so long.
We're all over halfway done, though.
Yeah.
Do we have to do bars? I don't want to keep going from one to the other.
No. You don't
No?
have to.
Okay. So I just go.
So 26, we're using the one sample T for proportion, right?
I haven't even looked at it. I think it's one proportion.
Okay, let me just compare what I have to what you guys got. The test statistic is 6.579.
Hold on. That's 6.579, yes.
Okay, thank you. The p-value is 0.087.
Yes.
Okay, so this is, should you reject? No. So on 24, what did you put? Either B, oh, there are many choices, okay.
24, we did B. No, the p-value is greater than 0.05.
Okay, great, thank you.
And then, okay. Sorry, Mildred, have you gotten 25 yet?
No, I'm reading it. So because we failed to reject, right? So that means that we have the being a morning person is independent. Is it B?
B.
Insufficient
We
evidence.
have insufficient evidence to say that being a morning or evening person is not independent of A.
It's not insufficient evidence to say that being a morning. So it's A, B, it's C, right?
I put D.
Let me see.
25 is D, in that we failed to reject the null hypothesis. So the alternative hypothesis is not true, so we have insufficient evidence to prove that the alternative hypothesis is true, which the alternative hypothesis is not independent of age. Very wordy and confusing, I know. I don't know how to put it simple. And then, Jamie, with your question for 26, I think it is the one portion.
Okay.
Do
For the lower bound, if I did it right, I got 0.402.
hold on.
I got 0.190.
Point what? What did you
190.
put for X and N?
I put 50 and 200.
Oh, yeah, I see where I just went wrong. Hold on. 0.190 for the lesser and 0.310 for the upper.
Yeah, that's all.
Yeah, I actually put 100 instead of 200.
Ah, gotcha.
So we didn't read that one.
No, sorry, it's right in our head, but we can read it with you if you'd like, Mildred.
What did you put for the null hypothesis? You just kept it at 0.7.
0.2.
Why? Oh, 20.
Because, yeah.
And then would it be less than?
I noticed that part didn't make a difference
Okay.
for it. It changes the p-value drastically, though.
Guys, how are you doing number 26? How are you solving that?
With a 1 proportion.
With the Excel file.
Oh,
So wouldn't it be greater than though because you're outperforming?
Are you just wondering about the last column?
Yeah.
Mm, I mean, you could. Well, it doesn't change the answer, so
It changes
maybe.
the value though.
Okay. Mm,
Do you need to know the p-value?
mm. Yeah, but if it was needed, I think you're right in that it would be greater than because of the outperform. So if that comes up.
okay. On question 26, is just 0 the lower bound?
On 26.
Because it's one sample z-test for one proportion, right?
Yeah, yeah, it's a one proportion, and so you would put a 50 in the X and 200 in the N.
Okay, so the lower bound is 0.19, right? And the upper
Yeah,
bound
0.
0.310.
Yeah.
Yeah.
How do you do 28?
I think it's N equals Z star over M to, how do you say that, to the second power? You know,
What? Squared?
squared, that's the word. Squared, so Z divided by M squared.
I'm sorry, say that again. What is the formula?
So solve for N, it's N equals Z star divided by M squared.
Isn't it 2
So,
squared?
what?
Isn't it n equals z divided by 2m squared?
Isn't
It's 2m.
2M?
2m.
Okay. It may be. I was just looking at trying to find an N one. I found,
I found. So it's n equals right there. N equals z star divided by 2m squared. I don't know. But I think that's it.
But then what's m? Do we have the value of m?
yeah, we did.
0.2.
Yeah,
Wait, no,
it's
point
Oh,
oh,
0.2. Yeah.
0.02.
Oh, 2.
And the z is The 1.96.
Yes.
I got I got 2,401.
That's what I got
Yeah.
too.
Before you told me the 2m, I was doing the z star divided just by the regular m squared and got 0.960. And then I did it the equation you told us, and I got 24.01. And so,
We got 24.01.
I got
yeah.
2,401.
I got 1,225 because it's 196 divided by 0.04 squared, right?
Yeah.
1.96, right?
1.96 divided by 0.04 squared.
That's what I.
That's what I did. So
And
1.96 divided by 0.04, and then I squared it.
Uh-huh.
And I got 2,401.
I don't know. I got one. Let me see. I'm going to do it again.
yeah, I forgot to put 0.04 and just put 0.4, but I did it again and I got the 2,401. So I think,
Okay, what did you get? 2401?
yes.
Yeah. You know what? I didn't close one parenthesis when I was doing it. So
Okay, and 29. Which is,
Let's see. Perform better. So wouldn't it be the second to last one? And then to make sure that P is normally distributed,
Isn't that A?
it's A or it's the 5 one.
that's what I
no,
think.
I think it's A.
Okay.
Yeah, I think
5 is for the chi square. I mean pi square.
I think it's A as well.
No, it wants a test statistic. Isn't it
Is the
.039?
no,
For what? For the test statistic?
is minus 13.887.
I got
What are you guys,
1.768.
what are you guys even doing to get the test statistics?
It's right in it's Z.
The 1.768?
Yeah.
Oh, I was looking at the p-value.
Really quick, what test are you guys running?
One sample z-test for greater than.
Wait. Are you guys on this? Is this the same one on that we just did on the one sample? Yeah. So it's greater than? I thought it was less than.
Well, for this one, isn't it? Are we referring back to the original question, or are we going as far back as 29? Because 29 it says performs better.
Oh. I don't know.
29 is greater than. Greater than.
Okay.
So
It doesn't affect the z-score though.
Okay. So it's 0.039.
1.768. Oh, wait. Oh, for 32.
Yeah.
Yeah. 0.039.
Sufficient evidence, yes.
So what did
0.04.
you do? You changed the values on the no. You changed the values on the Excel sheet?
We're using the same information as we were using on the past question.
Yeah. So X equals what?
X is 50, N is 200, the confidence interval is 95, and the hypothesis is 0.2. And then the type of test is greater than.
Okay.
And
Oh, what I did? Oh gosh. See, you have to look at everything. The null hypothesis. I forgot to change it.
33, I got A.
Okay, I got no. No, I failed to reject. Oh, duh, because, hold on, sorry, it is A. Because I had it different. You're right.
I really hope we do well on this when we submit it.
Seriously.
So the next one requires this.
Oh gosh, that's a long one. Okay, who's reading?
I can read. Computer software is commonly used to translate text from one language to another. As part of his PhD thesis, Philip Cohen developed a phrase-based translation program called Pharo. The quality of the translation can vary. A good translation system should match a professional human translation. It is important to be able to quantify how good the translation produced by Pharo are. The IBM T.J. Watson Research Center developed methods to measure the quality of a translation from one language to another. One of this is a bilingual evaluation understudy. A BLEU score is a number ranged from 0 to 1 that indicates how well a computer translation matches a professional human translation of the same text. Higher scores indicate indicate a better match. BLEU also, it helps companies to develop translation software to monitor the effect of daily changes in their systems in order to weed out bad ideas and good ideas. To compare Pharaoh's ability to translate from similar computer translation softwares, Cohen took a random sample of 100 blocks of Spanish text, each of which contained 300 sentences, and used Pharaoh to translate each of those into English. The BLEU score was calculated for each of the 100 blocks. These scores are recorded in the data file BLEU scores. He wants to use the data to see his mean BLEU score differs from the mean BLEU score of other leading translation software with a population mean score of 0.295. Assuming the requirement is satisfied, construct a 95% confidence interval for Pharaoh's true mean BLEU score. Record your answers below. So input the lower and upper bound for question 34 and 35.
So you do to analyze and do means, or compare means.
I'm pulling mine up there.
I just did the one sample t-test on it.
Okay.
Is that what we're supposed to do?
I think so.
Because then for lower bound, I got 0.282, and upper bound, I got 0.293 after rounding it.
That's what I got as well.
That makes sense.
The next one, I was a little confused.
Hold on. Okay. Oh, this one is when you do it to calculate in the box. When you do this one sample t-test, you need to put 0.295 as the test value.
Is that all you do?
Yeah, and
Oh, that's easy.
so descriptives or compare means, one sample t-test, and then 0.2 what?
9.295.
I think that's what you do from what I remember. So the
Are you
degree
getting like
is 99,
90?
and then the test statistic is negative 2.803.
Mm-hmm. Yeah, I got that as well.
Anytime that it says like, oh, we want to see if this is satisfied with the hypothesis, you have to put that number that it's equal to into the test value. And then if it doesn't have anything, then you just put 0.
That's good to know.
I learned that from my tutor.
So then for 38, you take the significant, right? The 0.006? Or do you divide that by 2?
It's one.
You do not.
It's equal to, so it's two-tailed. Or it's not equal to, so it's two-tailed, right?
It's 2, so it's just 0.006. You're not going to divide it.
So if it's not equal to, then you divide it.
Yeah. If
Yeah, if it's less than or greater than, it's one tailed test, so then you'd have to divide it by 2. But this one you do.
So then this is less than, so we have sufficient evidence to say that it's not equal to, right?
I think it's A, we have sufficient evidence to say that the mean is different.
I was thinking A.
Wording wise, the equal is different. It's A.
Guys, what did you get on the lower bound? 0.283, no, 0.282?
Yeah.
Yes.
And for the upper bound, 0.293?
Mm-hmm.
And the degrees of freedom will be 98 or 99?
99.
90? 99?
Yeah.
99. Which one is the one that we have to take one? Oh, never mind. I always get confused with that too. It's the number. Okay.
Is 40, do you do the whole difference thing? Or? Yeah, define the differences. You have to compute, forgot transform, right? Yeah.
Now for the p-value, what did you put? 0?
No, it's 0.006. Two-tailed test.
But here it's just 0, 0, 0, 3 zeros. How did you come up with the 6?
You need to change. You have to change the test value before, because in the equation it reads that the test value is 0.295. So when you run the test, you have to change the 0 to 0.295.
I have a question for 40. Do you you do the compute variable or encode or whatever, and then you do the difference?
Yeah.
And then what do you go to after analyze? Is it paired sample? No. What do you go to after that?
It's just another one sample teach, and you're just moving the difference. I feel like I've forgotten everything.
Right? You want the difference?
Yeah.
What
Now
function?
you're just computing.
So I got a negative 10.455.
Okay.
Guys, what did you put on 39?
A.
Which one?
A.
So Ashley, which one did you were wondering about?
Did you get for 40 negative 10.455?
No, I got 8.728.
What did you minus the AM first, then the PM?
Let me go back and check. I believe that's what I did, but I would have to.
Because I did PM minus AM, and that's probably what was wrong.
I just want to make sure I tell you. Yeah, I did AM minus PM.
I don't know. I forgot which one went first.
I think it's
I would
just the
think
order.
AM went first.
Okay. Then let me redo that.
Oh yeah, it says define the difference as AM height minus PM height. So then it's the 8.728 number?
Yeah, so the lower is 8.728, and then the upper is 10.455.
I still have a question.
A.
On 40, you have to transform the data, right? You have to do the
On 40, yes, you have to find a difference. So you're going to do AM minus PM, and then you're going to do the one sample t-test for the difference.
yeah, but where do you do that? On transform? Compute variables? I forgot.
Yes,
Compute variables, right?
yes.
What function group and stuff did you use for that?
Function group?
Yeah, under the compute variable thing.
So then compute variable.
Oh wait, never mind.
I'm not quite sure.
I got it.
And then is anybody
Okay,
else
so
on?
after I do the difference, I go to analyze, right?
Yeah.
Compare
Nice.
means. So which one are we doing here?
Run the difference.
Which one?
Difference.
No,
The
no, no.
compute means you just
Yeah, no, after that's done, when I'm analyzing the compare means and then to
do one sample t-test.
You get 22.446.
Yeah, that's what I got.
Okay, then
Has
40.
anyone else gotten like freedom or p-value?
Yeah, I got 40 for 43 and then 0 for 44.
That's what I got as well. And then I said the yes because it rejected.
Yeah. Me too.
Wait, what'd you get for 42? My system crashed.
22.446.
42.146?
No, 22.446.
And then for the degree of freedom?
40.
And what was the p-value?
0.
And then the last one is C.
Yeah.
41 out of 43.
Oh gosh,
Oh, no.
sorry guys.
Which ones did we miss?
I'm checking. Hold on. 28 is wrong with the 2,401.
Okay.
And sorry, there's a lot of questions. And 8 is wrong,
8 and 28.
which is like choose the test. And I put independent sample T for that one.
Yeah.
Okay, A, I think it's the one sample T confidence interval then,
Okay.
because we're comparing it to what's already been said. So we're just running the one test.
Okay. And
I'll
then
try that one.
What about for the huge number one? Because I have no, I couldn't think of another way to do that.
oh, I know. I do. I think I know. So we know the prior estimate. So it's n equals z star divided by m, and then p.
Then you're missing the last part.
Oh,
What? And then you times the right
Yep.
yeah.
by p.
Oh.
It's p times 1 minus p.
Okay, that's what I
Yeah.
thought. Okay, so the answer would be 1 minus 0.2 times 0.2, and then 1 times 6, so it's 0.16. So 1.16 divided by 0.2 times 0.16. I got 15.68, so I would say 16.
What was the answer you got?
I got 16.
Okay. I'll put 16 and try it. Okay.
Guys, I need to compare what I got for 40.
40 is,
17.22, did you get that?
no, I got 8.78.
Yeah.
728. And for 41, I did something wrong here.
41, it should be 10.455.
450.
No, 10.455.
Michaela, did you?
10.455
Yeah, I'm scrolling down right now.
and 42.
I got 42 out of 43. Let's see. Okay. Yeah, I missed question 28.
What the freak?
I need to take off, but good luck on the test, everyone.
Are you good? Hey, I have a question. So when we do, I sent you my all my data, but we do it separately too and submit it.
Yeah, I think for submission we have to submit it all separately, but then all together I'm just going to combine all of our data and put it in one sheet and then send it out to all of you.
And then we'll just submit that.
That's just for our
No,
personal.
I think you still need, yeah, I think we still, from what I understand what he's asking us, is we all submit ours individually, and then I'll just give everyone the data so that we can all run the test, because we're going to have to, like, probably put graphs or something in to compare. So,
Guys,
I think
what
it's
did you
individual,
get
but
on
I'll still send it.
42?